Section 1.4 is titled Powers and Exponents. The vocabulary term I'd like you to learn today is power. This is an expression that's written with an exponent and a base, or the value of such expression. So if we look at 3 to the second, the base is the number that's used as the factor, so the 3, the larger number. The exponent, which is the smaller number, the 2, tells how many times the base 3 is used as a factor. So you want to remember the larger number is the base and the smaller number is the exponent. So let's look at a table where we're using the number 3 and writing it as different powers. So in words, we would say 3 to the first power. When we write it as a power, the base is a 3 and the exponent is 1. That means in the multiplication column, we have 3, just one 3, and its value is 3. The second row, we have 3 to the second power. We write that as a base 3 and an exponent of 2. It means 3 times 3, or 3 multiplied by itself twice. There's a nickname when something is raised to the second power, and that's squared. So another way to say it is 3 squared. 3 times 3 then is 9. 3 to the third power would be the base of 3 and the exponent of 3. And it, in multiplication, is 3 times 3 times 3, or 3 multiplied by itself 3 times. There's another nickname here for this exponent, and that's cubed. Anytime something is raised to the third, we say it's cubed. The value of 3 times 3 times 3 is 27. 3 to the fourth power, we write the base 3 with the exponent of 4, and if we multiply that out or write it out, it's 3 times 3 times 3 times 3, which is 81. Finally, 3 to the fifth power, so you can see a pattern here, is a base of 3 with an exponent of 5, or 3 multiplied by itself 3 times, and if you do that, you get 243. This pattern then would continue on, so you can think in your head for a minute, what would 3 to the 10th look like if we multiplied it out? How about 3 to the 100th? How many 3's would we be multiplying together if we had 3 to the 100th power? And I want to make a quick note here. In the expression negative 5 to the second power, or negative 5 squared, the 5 is the base because the negative sign is not in parentheses. However, in the expression negative 2 to the third, notice that the negative 2 here is the base because of the parentheses. So if there are no parentheses around a number, but there's a negative sign out in front, the negative sign isn't included when you're multiplying the number. And we will look at some examples. So first, evaluate the expression. Number 1, we have negative 6 raised to the third power. Notice the negative sign is inside the parentheses, so that means it is the base, the negative 6. So we have negative 6 times negative 6 times negative 6. Well, negative 6 times negative 6 is a positive 36, and now we need to multiply by negative 6. And I don't have a calculator handy, so I'm going to do some work here up top. 36 times 6. 3 times 6 is 18, 19, 20, 21. So we would get negative 216. Remember, because a positive times a negative is a negative. Number 2, we have negative 10 squared. Now the negative is not in parentheses, so the number that we're multiplying twice is just 10. 10 times 10. That's 100. But we can't just ignore this negative. Now we're going to bring it out in front. You can kind of think of this as being negative 1 times 10 squared. So then you do the 10 squared and get 100. When we multiply it by a negative 1, then you get negative 100. Number 3, we have negative 5 inside parentheses, and it's being raised to the third power, or cubed. So we have negative 5 times negative 5 times negative 5. A negative 5 times a negative 5 is a positive 25. And we multiply it by the third negative 5, and you get negative 125. That one I do know. Number 4, we have negative 6 squared. Think of it again as a negative 1 times a 6 squared. So 6 squared is 36, but we need to multiply it by that negative 1, so we get a negative 36. Number 5, we have 3/4 being raised to the third power. So don't freak out because it's a fraction. All it means is we've got 3 of them multiplied together. So 3 over 4 times 3 over 4 times 3 over 4. When we multiply fractions, we multiply across the top. 3 times 3 is 9. 9 times 3 is 27. And you multiply across the bottom. 4 times 4 is 16. 16 times 4 is 64. Now you would check here to make sure that this fraction doesn't reduce, but I can tell you a trick. If the original fraction didn't reduce inside the parenthesis, then your answer won't reduce either. There's no number besides 1 that goes into both 27 and 64. So that's your final answer. Number 6, we have negative 2/9 squared. Notice here the negative is outside the parentheses, so it's not included when we're squaring the number. So we'll put the negative on at the end. Remember, you can think of it as negative 1 times 2/9 squared. So we're doing 2 over 9 times 2 over 9. That gives us 4 over 81. But we have to multiply it by that negative 1 or bring that negative sign along with us to get negative 4 over 81. Again, this isn't going to reduce because 2 over 9 doesn't reduce. Now I want you to learn how to write each number as a power of the given base. So if 64 is the number that I want you to write, or to get as an answer if a base is 8, ask yourself, how many times can I multiply 8 to get 64? Well, 8 times 8 is 64, so your answer here would be 8 squared. Now we want to look if we have a base of negative 3, how do we get to 81? Well, let's not worry about the negative sign just yet. Let's look at the number. 3 times 3 is 9. If we multiply it again, we get 27. And one final time will give us 81. So we know it's going to be 3 to the 4th power. But because the base needs to be negative and our answer needs to be positive, we would want all of these 3's to be negative, because a negative times a negative would give us a positive. If we look at the last 2 3's, we'd be in that same case, and we would be multiplying 2 positive numbers. So we're writing negative 3 in parentheses and raising it to the 4th power. Number 9, we want to get 64 with a base of 4. And we actually just did that on our last example. We saw down here on the bottom that if 4 was being raised to the 3rd power, 4 times 4 times 4 is 64. So we would say 4 cubed. Number 10, we have a base of negative 3, and we want to get to negative 27. So how many times do we need to multiply 3 to get 27? Well, negative 3 times negative 3 would be a positive 9. And if we multiply it by another negative 3, we would get negative 27. So we want negative 3 raised to the 3rd power. Something that you'll notice, when you have a negative number inside a parentheses and it's raised to an even number, your answer will be positive. However, when you have a negative number raised to an odd power or an odd exponent here, then your answer will be negative. In class, we're going to work on worksheet 1-4.